Hello everybody. For those doing the resit or doing this for the first time for engineering, it's Unit 3, Engineering, Product Design and Manufacturing. I'm just going to go through a few things to help you on your way for this one. It's two parts. Part A, which is the research task, which I've got in my hand here, and yellow ones. Part B, don't panic, 2 bits of paper. There's part B, and there's quite a thick booklet on there, and there's the information sheet that goes with it. There, I'll talk about those later. Okay, but the first one I want to do is talk about this. Now, I'm not going to flick through here as we go along. It's a bit pointless, really, to do that. What we do is I'll do it electronically and share my screen on there, so it'll be a lot easier for you. Okay, so I'm just going to share my screen. Give it a second or two to like start up. Okie dokie, as you can see, so I've got a full page. You can see exactly what I was holding up. It's the same one, the exam date that you see up here, the paper reference. So when it says what paper was you doing it, you always record, you always give it that number there, and away we go. So instructions on this. Now, a lot of you'll be keen at getting to nitty gritty. Just go through the first couple of pages. So the first page, just go full width, is the instructions for the teachers. Don't worry about that bit. We worry about that, okay? The second page is the instructions for the learners, as you see there. Read the set task information carefully. This contains part A, which is information you need to prepare for the set task. You need to carry out your own research over the next week, and you could take up to 2 sides of A4 paper. Individually prepared research notes into part B. These are the bits that you'll take into the exam, right? Actually, we'll print those off for you, and we'll take them. And when you sit your exam, they'll be there for you. So if you are listening to this from another school, just make sure you get these printed, and your exam will be there waiting for you. Okay. You must work independently, as you see here. You must not share your work with others. The teacher will give you guidance on when the preparation should be completed, but it cannot give you feedback. That's, you know, don't ask us to say, what do you think of that? It's not going to happen. Okay, it's coming down to you. It's your exam, your qualification. So moving on to the next page. Here we go, scroll down, set task brief. So for this particular example, and it says there, you are advised to spend a maximum of 3 hours doing your research. You will be sitting in the room for a 3-hour hit doing this. You might get a tea break, depending on your school or business or your college, but you should get a tea break to give you a break in between there. Hour and a half on the screen will make most people's eyes strain as well. We're not here to kill you. So as you see here, read the first one here. A client has asked you as a technician engineer to optimize the design of a shelving unit that is not effective. The shelving unit holds industrial castings that need to be stored before further processing. Okay, the shelving unit is manufactured in batches of 1,000. So again, just read it through what you see. Don't think about anything, just read it through. Your research the design and manufacture requirements that are relevant to the shelving unit and its use. Your research should consider existing designs for the industrial shelving units, the manufacturing processes and technologies that are being used and possible alternatives, material requirements and suitable material properties, including corrosion resistance, the health and safety requirements for the product, user and manufacturing processes, environmental considerations including sustainability, and any other relevant factors such as the application of semi-permanent fittings and fixings, methods, mechanisms to enable easy use of and designing out risk. Okay. In part B, you'll give them further information on the specific issues with the existing shelving unit that will allow you to redesign the shelving unit and evaluate it against the issues. Therefore, you're advised not to undertake any design work during part A. It's not design work, just a research stage, as it says here. You'll be able to take up 2 sides of individually prepared A4 research notes from part A, part B. So if you get these up, set up your Word document, for 2 pages. Anything over 2 pages will not be printed off. It'll just be the first 2 pages. So make sure you edit and format your pages. Moving on to the second page, the set task information. This is all they're going to give you. Just go with a full page on that one. This is all you're going to get. Okay. Have a full width. The product is the shelving unit. The shelving unit consists of 3 shelves, 4 shelving supports, and 12 shelving rods. The shelving rods are positioned into 10mm deep blind holes in the shelving supports and then welded into place. The shelves made from folded sheet and are located onto the shelving rods throughout 2 holes in each side. The shelving unit is manufactured in batches of 1,000. The shelving supports, and shelving rods are made from low carbon steel that is spray painted. So let's go and look at this. Just have a look. Just exploded view on here. So generally you see these 2 posts here. You'll see a post here with the rods that you see here and here, and you'll see the element of the hole that go through. General sizes of this, and if you look at this, detail B, which is this little view here, showing there's a hole in the shelf for the rod to go in. Detail A, as you see here, so it's done a hidden view, so it's a tubular support with the rod, which is welded in position, which goes through the hole. And if you look at the hollow section there, is there a section bit on here? No, it doesn't say that. So hollow rectangular section of the bar, you can see how thick the walls are, and the rod, which is inserted 10mm, and there's a little weld on the outside holding that rod in. That's all it is. Okay, that's what you got. Keep looking at the old dimensions. Just reduce this a little bit. So go on that, page 5 is the last one. Length, width, and height. That's all you have. Made from 2mm folded sheet, shelving rod, shelving support, all dimensions in millimeters, 1,400mm high, 400 width from front to back, and then you've got the overall length, and this is from the front side of the support shelf, sorry, shelving support post to the other side of 1,120. That's all they're going to give. Okay, so without further ado, I'm going to just go back to the first page, as you can see here, and all you need to worry about is, can you give me something for these bullet points here? 1, 2, 3, 4, 5, 6. That's all it is. I need something for these. If you miss one of these out, you're going to go in there with, it's like going football with his shoelaces, not on his boots. You need to make sure you have all your stuff there. Okay, so the research, you will research the design and manufacture requirements that are relevant to the shelving unit and its use. Your research should consider, when it says consider, just say you better do it. Just say you better look after that, okay? So existing designs for industrial shelving units. So that's the easy one to do. Just go and find them, right? Now they're not after, please don't just take loads of pictures of different types of shelves and that's it from a distance. We try not to produce an Argos catalogue, okay? So you're looking at some shelving units and the detail that you're after is how it's put together, okay? Now, is it a welded construction out of sheet metal welded together? Is it sheet metal which has been folded and then bolted together? Is it using quick release, a zero bolting shelving unit? You need to go and find those bits and pieces. Now, if you're not sure of a lot of things, you're going to have to learn the hard way, hard and fast on this. So images of existing shelves and how they go together. So that's your first priority, how it goes together. 2, zooming in to see what the shelves are actually made from. It might be a wooden shelf, it might be metal shelf supports with a wooden shelf on top, blah, 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 that sort of stuff. So you're looking at those sort of things. Bullet point number 2, okay, the manufacturing processes and technologies that are being used and possible alternatives. Your images will give you the idea, the ideas that you want. Manufacturing processes on here, okay, is it a fabricated part? If you look at most shelves that you'll see, excluding the stuff you see at IKEA. If it's something for industrial, it's metal rods. That's all it is. No tubes. It's just metal folded into a certain way to give it some reduce the flexibility of a sheet metal to make it rigid. And then all you've got to do is make sure the shelves go in on top of those. Just make sure you have something there on that. Manufacturing processes. So the simple that. So fabrication. So you'll have the shelves that need to be laser cut to cut the parts out. It could be plasma cut. It could be water jet cut. You've got a good selection there. So you can now have a blank, because the blank has to be folded. Okay, so how are you going to fold it? On a manual thing. Just remember there's a thousand of these to be produced. So think about automating the process here. So think about using a CNC brake press, or it could be just a manual brake press. They do the same thing, but the manual brake press is where you'll just do one bend at a time, and it's set just for that one bend, and it doesn't adjust itself. Okay, so I'll let you look into that sort of stuff. Technologies, so laser cutting. So where we used to do plasma cutting, you could have used a punching machine which would have nibbled it all the way out. That's called a trump, so you might need to be looking at that sort of stuff. Laser cut machine, as I said before, water jet cutting machine. The problem is water and mild steel isn't very good. It'll make it go rusty, so you need to make sure you dry it off and then add the protective film on that business and go through there. Being used to. So just look at all the possible alternatives. For shelving units, you're not going to see solid billets being machined to the 7 shades of light to make 3 mil walls. It's not going to happen. Shelving units will probably be will be a fabricated process. Now, going to the third bullet point, okay, material requirements and suitable material properties, including corrosion resistance. Okay, material requirements is basically got to be tough. Okay, it's no good making it out of paper; it just rips. If it gets wet, it's going to tear and just rot to bits. Suitable material properties, so you need to make sure that it's strong, rigid, and something like that, but soft enough so it can bend, and include corrosion resistance. Okay, so think about, well, if it is made out of mild steel, I'll have to paint it, won't I? Okay, so it already says this one's painted, so that's one way of including corrosion resistance. Or do away with the painting and use something that's not corrosive, something like stainless steel. Okay, only problem is stainless steel is more expensive, so you now start to see stainless steel expensive, mild steel is cheap, but you have to add another process to spray it. Okay, which mild steel and the process of spraying is probably still cheaper than stainless steel as you go from there. So just think about those. Put something for that point there. Now, the health and safety requirements for the product, user, and manufacturing process. Okay, so someone's got to use it. So if you go to IKEA and buy a bully bookcase, they will say to you, you've put this together, you must bolt it to the wall. Okay, so if you get squashed by the bully bookcase, IKEA says, well, we've already told you that you must strap it to the wall. You failed to do that, you ain't got a leg to stand on. And this one's coming down health and safety requirements of the product. Okay, you know that paint does not have lead in it now because it's poisonous. So it'll be a lead-free paint. Think about other bits and pieces that go in there. The user, so the people, the user, they need to put it together. So make sure there's no sharp edges. So you need to make sure anything in the sheet metal is all fully deburred, no sharp edges, blah 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 blah. And the manufacturing process, that it's safe as well for the manufacturing process. These are sheets of metal, so you're not going to use 5 or 6 mil thickness material. 5 or 6 mil thick material because it's just too heavy. The person won't be able to lift it. So going to the smaller material, 2 mil, the person will be able to lift it as well. And plus, if they're cut profiles, they ain't got to lift the full sheet. They just lift up the part which needs to be bent up for it. Going on to this one here, environmental considerations including sustainability. If you look for, let's say, if you look for someone on the Google search, environmental considerations, including sustainability in manufacturing or design, engineering design, it will go up with a little bit of spiel on that. Okay, don't overthink this one. Just grab something off the internet there. Other relevant factors that you see here. So I'm going to split this up into a couple of bits. Other relevant factors. Now we're looking at such as application of semi-permanent fittings and fixings. Okay, which is this one here as well. Oh, just get that again. Semi-permanent fittings and fixings. Okay, so we're now looking at that. So are you going to bolt it together? Right. Bolts become semi-permanent fittings and fixings because they can come apart and go back together again. If you decide to rivet it with a pot rivet, they are semi-permanent fittings, but you have to drill them out and get a brand new one to go into place. Fixings and stuff like that. So think about so if you remember on this, the one that's got rods to locate the shelf on the rod through a hole. Think about how these are located on the thing. So you fix it in position and then you fit the nuts and bolts in or whatever like that. You may decide to just weld it and something like that. Methods and mechanisms to enable ease of use and design and out risk. Okay, now we do not know what the problems are. Okay, but if you look at this thing here, there's no nuts and bolts holding it together. It's going to rack around like a nut job. This one, the pins that you see with these welded rods, there's nothing holding it in. If you look on the inside, not like a nut and bolt where there's a nut holding the position. There's nothing, so that could slide off. If you look at from front to back, it's going to be rickety rackety. So from this bit here, imagine that tilting to the right like a parallelogram, and then the thing slide out. That's dangerous. No one's going to use that. If someone give me that to put together, I'll say, no chance. You sort it out yourself. Okay, as you see, there is no problems or issues that are here. It's just coming down to researching shelves. Going back to that, going back to here, you need to make sure you hit everything for here. Okay, for that bit there. Existing designs, as I already said in the beginning of the video, manufacturing processes and technologies that are being used for personal alternatives material have something for each one. So that one there be section 1. I would be using about half a page to 2/3 of a page there. Okay, don't be shy of putting zooming in on certain features that you want to take advantage of. So if you can't remember how it's stored together, just put a picture of it as you see in there. Okay, there's nothing wrong with you drawing on a piece of paper, take a picture of it and insert your picture on your A4 sheet as well, just to help you out there. Processes and stuff like that. So there'd be half to 2/3 of the page for that one there. Manufacturing processes, technology, and that business. If you are more of someone who needs photos, put relevant photos. Don't forget to label them. You need to label the images that you put on. Otherwise, it's not worth putting anything on there. You know, might be a week or 2 weeks before you get onto the next one, to the real exam. What's that picture in for? So make sure you label everything. Material requirements, okay, and something like that. And corrosion resistance, that's your requirements. So that's one part. Suitable material properties, there's another part, and inclusion of corrosion resistance in another part. If you just do the first bit and forget about the rest, there's material that you could have added to your research notes that's gone missing. You don't need to do it. Just make sure you add everything you see in there. If you look at this one here, the health and safety requirements, right? So there's 3 bits here for the product, okay, for the user and the staff manufacturing it. Okay, so health and safety, just write something about each one. So there's nothing wrong with putting a 3-column table and make sure that health and safety requirements is the top one, and the column 1 will be for the product, column 2 for the reuser, and column 3 will be for manufacturing process. Bullet point all your bits and pieces there. You ain't got time to write Shakespeare. 3 hours will disappear before you know it. Environmental considerations. So think about that one first. Give yourself some information on that, and include the sustainability. Give yourself on that. So this would be adding to another page. If you go in there with a page of very, let's say, vague information, your exam is going to be very vague as well. Okay, so make sure you have that covered. Any relevant factors, such as the application of semi-permanent fittings and fixings. So look at those. Okay, so you've got the images from the existing designs of that business. So how did they put it together? Use those for your semi-permanent fittings and fixings. Okay, methods and mechanisms. Okay, now this has not got a drawer, it's got a door, no hinges and that sort of stuff, but what it's got is the method of joining the shelf to the uprights. So how did they do it? Use your images. If you need to take a go back to the web page, get that image, take a larger shot, bosh, stick it in. To enable ease of use. Okay, so methods of to enable easy use. So you remember when I said the shelving units could be a boltless system. So you now need to make sure that the method of putting it together without bolts, you've got to give the detail how it goes together. So it'd be slots, keyways and slots, and protrusions and that. You've seen them, as we've done this quite a while ago. Those who haven't done this, seen it for the first time, you really need to be seeing how this goes together. So you can have the good old-fashioned nut and bolt, good old-fashioned boltless system, good old-fashioned rivet together. So you line the holes up, put a rivet in, and pop the rivet as well. You could do it like that, and so on like that. Now, designing out risk. Okay, I'm going to draw your attention to that shelf again. There is no way that is safe. Okay, that's going to rack around like a nut job. So there's no nuts holding the rods, holding the shelves in position. That'll slide apart. Basically, as soon as you put any weight on that, that'll fall apart on you. That's dangerous. So design out risk. So the simple thing is that it's a rigid construction, does not come apart, does not rack, and sturdy. Okay, sturdy on that one there. So there's not much more I can say about this, but you've got 2 A4 sheets to get as much information as you can on this bit here. Okay, you already had so the resitters for this year, you already had to go. So you had an advantage on here. Now, I do not know what the exam's all about. It could be anything. Okay, now we've done enough processes we've done the fabrication, we've done forging, we've done casting, we've done how stuff is cut for fabrication, laser cut, water cut, plasma cut. The folded mechanisms with the brake presses, CNC brake press, like business, machining. So you've got manual machining, turning and milling. We've also got CNC machining, so going like that. We've covered so much in class. You should just go through that. Now, if you see something which is going to be more of a fabricated part, don't worry about casting. Don't worry about those other bits and pieces. Annotation is going to be your friend here. If you put very little notes, you won't be able to put anything on there. Just make sure you have something about that and the suitable materials, and include corrosion resistance. All right, two or three bits and pieces. I already said paint it. Already said about change the material for stainless steel. So you don't have to paint it. And go blah blah blah. I'm just going to now stop sharing my screen. Come back to the video that we have here. It's quite a fair bit to take in. All I want you to do is give it a good go. If you put the notes down as much as you can in detail. Now, don't forget, you can shrink the font. As long as your eyesight can take the size 8 font, you can shrink that and get a lot more information on there. Okay. Health and safety requirements of shelving. Just look what other people are doing. Environmental considerations including sustainability. Copy and paste that stuff in. Don't go and try and figure it out. This is a research task. It's not a task that you have to write yourself. You know, you have your sketch. You might have some sketches. So you do have some sketches. Put them on a plain piece of paper. Okay. take a photo of that, cut it, send it to via Teams, add it to your notes. You've got 2 sheets of that. One side, 2 sides. That's all you got. You've got nothing else. So if you do go at page 3 and 4, you're only going to get the first 2 printed for you. So you must make sure they come in. I wish you luck again, boys and girls. Please don't let it worry you. Make sure that you do turn up on time. If you come in 10 minutes late, you're going to lose 10 minutes of your exam. So make sure you turn up on time for that. Right, over and out. See you all about when we're back at college. Engineering Geezers out. Bye.